What if I told you that your flow does absolutely nothing until someone starts collecting it? That's exactly what makes Kotlin Flow so powerful, and also confusing for many Android apps, including me as well in the past. In this episode, we are diving into one of the core concepts of Kotlin Flow, which is cold flow. We will understand what cold flow actually means, how multiple collectors behave, practical Android examples, and how to convert a cold flow into the hot flow. Once you clearly understand the difference between cold flow and hot flow, then many advanced API like shade flow and state flow will start making much more sense. So let's jump in and understand the cold flow. So what is cold flow? A cold flow is a stream of data that stays inactive until someone starts collecting it. In simple words, we can say that no collectors means no execution. There are few characteristics of cold flow. So before that, we see our example code. In the previous video, we make a counter repository, and in that we have created this get counter method. And here we are using this flow builder method to create a cold flow. So this code of flow, the first characteristic is this is lazy execution, means the code inside this block will not be executed until someone starts collecting it. So to test this cold flow, we will create two buttons on UI side. So in our main activity, I have already created this UI which contains two buttons. So in the main view model here, I will create a function named as, actually I will comment out the existing collector which are in the init block, and in here I create a function named as button1 on click, wrap it into view model scope dot launch, because we cannot collect flow from a normal function. So counter repository dot get counter. So at this point, if we do not call the collect method on this get counter method, then we will then this part of block will not be executed. So here we will use the dot collect, and in that we have the value, so print that in log, and we will call this button one on click from the UI side when user tab on button 1. So here button view model dot button 1 on click, and we also do some modification in this counter repository. We will remove this exception from here and add an artificial delay to observe some certain behavior on the in the logs. Okay, so let's run the app and see this logs information from the logcat. Here I will add a filter button 1. So when we tap on this button 1, then we start collecting data from the flow. So we will observe these values in the logcat. Okay, and now, so this is the first characteristic of cold flow, that it's a lazy execution, that whenever any collector will start collecting the data from the flow, then the body of within this, then the code in this flow will be start executing. So if there are two collectors collecting the data from the flow, then each collector will have the separate execution of this code of flow. So we will see this through this example. Let's say I will select this code and press Ctrl D to make a copy of it and rename it at button 2 on click, and also change it to button 2 on click. And in the main activity, here I will call this view model dot button 2 on click, and now let's run the app. And in the logcat I will clear the logs, and we want to see the difference that how we are getting data from the both in both collectors. So I will split it on right side and make a compact view, and also add a filter button to here. Okay, so our app is up and running, and now I will tap on button 1, and this collector is getting data. If I tap on button 2, then I'm getting this value. So both these collectors are the separate execution. So this is our second point, that independent stream, that each collector has its own execution, separate execution. And the third point is no data caching, that code flow does not store or remember any previous emitted values. So the next point is multiple collector behavior, which we have already observed by tapping on these both buttons, button 1 and button 2. And we also want to do some operations. Let's say uh, whenever the data collection from the flow has been completed, then there might be cases that we want to hide a loader, or show a success dialog, or show an information dialog. So for that certain case, we can also have the on completion method here, that when the execution of the flow has been complete, then this method will be called, so we can perform any certain action in this code of log. So I will copy and paste it for the button 2 as well. So let's run the app and verify this change through the logcat. Okay, so our app is up and running, and now I will tap on button 1 and button 2. So after the completion of the counter, the execution of the flow will be completed. So we are seeing this on completion in the logcat, but I am seeing the button 1 on completion 2 times. This is because I haven't changed it to button 2. Okay, and now converting a cold flow into hot flow is an important topic. But to truly understand it, we first need to understand hot flow itself. In the next episode, we will deep dive into what hot flow is, how it behaves differently from cold flow, state flow, and shade flow. And after that, we will come back and learn how to convert our cold flow into hot flow in a much clearer way. So in this episode, we learn what cold flow actually means and how multiple collectors behaves with cold flow. And in the next episode, we will deep dive into the most important concept of flow, which is hot flow. We will cover what is hot flow, understanding state flow and shade flow, how it behaves differently from cold flow, when to use which one in Android apps. So if you have any questions, let me know in comments below. Thank you for watching. Bye, and I will see you in the next one.